Phase 3, camera. So in this phase, what we're doing is we're going to control A, where the camera moves, and B, how the camera zooms in order to fit in the two tanks. So you notice in this footage, as the tanks are driving around, just watch the camera frustum up in the scene view here. Notice that shape is expanding and contracting as the tanks move further apart in order to fit them both into the view. And that's controlling that size value that I mentioned earlier about zooming, and we're going to talk all about that now. So currently we have a main camera in our game. We need to create what we call a camera rig. It's nothing special, it's just a way to use another separate empty game object to hold our camera. So there's a few different ways to create game objects in Unity, and when I say create game objects, I'm usually talking about either empty objects to store things, or I'm talking about primitive objects for prototyping or something like that. You've got the game object menu at the top, which you can go to create empty, or you can go to any of these other things. And then you've also got a create menu on the hierarchy. So from here, you can choose basically exactly the same thing. So this menu is the same as this menu up here. It doesn't matter what you use. So I prefer to use the hierarchy and right-clicking, because that also allows you to do the same things. But we want to just create a new empty game object in the root that's going to be our camera rig. So I want you to just click on the Create button on the hierarchy and choose Create Empty. We're going to rename this Camera Rig. And then we're going to position this, making sure that it's first off at 0. So there's a shortcut to that if you want. So if you're offset at the wrong position, you can always reset position by clicking on the gear icon to the right of any component. Choosing reset position there will put in zeros for you, just slightly quicker. For the rotation of that, we want to set it to 40, 60, and 0. So you'll notice that we're using the same rotation as we did for the camera originally, and you'll see why shortly. So very quickly, we reset the position to 0, and the rotation of the camera rig should be 40, 60, and 0, X, Y, and Z. Okay, then we're going to actually put the rig together. So we need to place our camera onto the camera rig as a child object. So all I'm going to do is just grab my main camera, drag, and then drop it onto the camera rig like that. One more time, grab the main camera, drop it onto the camera rig. Then what you'll see is that main camera becomes indented. Its name is slightly over to the right, underneath camera rig. Then what we're going to do is to tweak the position and rotation of that main camera. So just have a look over to the right at the transform component. And the positions will be just slightly off. So just slightly imprecise. So just reset them to 0, 0, minus 65. And the rotation should already be 0, 0, 0. So I'm just going to pop that where it's easier to read. Position of the main camera, 0, 0, minus 65. And the rotation should still be 0, because remember, we have made this a child object and it's inherited the same rotation. So as a result, its rotation is 0. Yeah, so just to run through those things again. The camera rig's rotation should be 40, 60, 0. And the camera itself should be all zeros.
Just a quick mention, the position that you see in the inspector is the local position of that game object. So because our main camera is a child of the camera rig, its position is local to the camera rig. So it doesn't have any variation in the X and Y coordinates, but it is further back. It's 65 units back, but no variation in X and Y.
Yeah, so note that our camera rig, remember we said reset the position, is on the ground. So I'm going to set that to global so you can see it. So you see these axis handles in my scene view right now. That's where that camera rig is. Whereas the camera is all the way up here. Minus 65 back in the local Z axis. So Z being blue there. Now we're going to just talk briefly about how this camera works before we dive into any kind of scripting and functionality. So the first thing you need to know about is a frustum, the hilariously named shape of the camera's view. So the frustum in a standard perspective camera looks like this. So you have these two planes, so a plane being just a flat rectangle, the near clip plane and the far clip plane. And between those 2 points is everything that you can see. So the difference between what we're doing with our game and what you'd expect with a perspective camera is that with a perspective camera, say you've got something up close near the near clip plane. When you then move that further away, it looks smaller compared to everything that it's surrounded with. Okay, so things like in the real world get smaller as they're further away. With an orthographic camera, the near and far clip planes are the same size. So as a result, you don't get any change in scale over distance. So what does this look like? So between those two cameras, you can see on the left perspective and on the right orthographic. And you can see that things get smaller. You can see our rocks look smaller than our buildings, whereas really they're probably the same height. Whereas in the orthographic view, things remain the same. So obviously this is used in a lot of strategy games. If you ever played things like, Command and Conquer, Red Alert, those kind of old school RTS games, then that's the kind of view that you were looking at. So the orthographic camera's size is how we zoom. So keep that in mind as we go through this theoretical part. And we zoom by changing that size. So just a quick reminder of what we were looking at earlier. As I change my size value for the main camera component, it zooms in and out. So during the game, we need to be adjusting that value to zoom, and then we need to be moving the position of the camera rig in order to follow stuff around.
Slightly counterintuitive to think of it, but as you increase the size of the camera, the frustum gets bigger, so more stuff fits in, so it looks smaller. So increasing the size will zoom out, whereas decreasing the size will zoom in.
So the other thing to know about is the camera's aspect. So if you're familiar with YouTube or video or TV in any way, then you'll know what 1080p is. So 1080p just represents a screen size of 1920 by 1080 pixels. So we think of this as an aspect ratio of 16:9. So 16:9 is our aspect based on those particular sizes. So to find the aspect of that being 16:9, we divide 16 by 9 and get 1.778. Okay, so the aspect, not the aspect ratio, the aspect of this particular example is 1.778. So what should our camera do? So those two things were just a couple of things to remember for this next part. Okay, so what should our camera do? Well, we need to follow the tanks, track wherever they're moving, and we need to resize, i.e. zoom, to fit the tanks on the screen. So this is the general kind of behavior that we're getting from the camera. As those tanks move apart in this beautiful ballet that we see, the camera is zooming out. The other brief thing to mention is you notice that the tanks never quite get to the edge. We have what we think of as a padding.
It's a screen edge buffer.
A screen edge buffer.
For the edge of the screen.
Yeah, that's what it says. And that stops the tanks ever, jumping off a screen. So that's the behavior that we're going for. Okay, so the next thing we're going to do is to jump into actually starting the script, and then we'll go a bit back to the theory, and then we'll carry on a bit at a time. So what I want you guys to do is to look in the scripts folder, and then you'll find a folder called camera, and there's one called camera control. Drag and drop camera control onto the camera rig, not the camera rig. Can't say that enough. Camera rig has the camera control script on it. Then we're going to launch that script and have a little look. So double click on the name to open it up in MonoDevelop or Visual Studio.
So this time we're not going to ask you to write any of the script. This one's already been completed for you, but we're going to run through it and explain how it works. We'll start off at the top again with the public variables. So the first one that you can see is the damp time, and we've set that to 0.2. So what the damp time is the approximate time that we want to take for the camera to move to the position that it's required to be in. So rather than it moving instantly, we're going to damp that movement a little bit, and that's how long we want it to take roughly. Then the next one we've got is that screen edge buffer that we were talking about, and all that is going to be a number that we add to the size to make sure that the cameras aren't at the edge of the screen, they're all the way on the screen.
The tanks.
Sorry, tanks.
You're welcome. Had to get one in.
Okay, so the next one is the minimum size. So we don't want the camera to get really, really, really zoomed in. It's going to look silly. So we set a minimum size of 6.5. So next we've got a little bit of a complication thing here. we've got hide in inspector commented out. So the reason that that is there is later we're going to come back to this script and remove those comments. So this variable is hidden in the inspector. Currently, what we want to do is set our tank to be followed by the camera. So we want it to be one of the targets. However, later the game manager is going to set the targets. So we don't want to be able to set it in the inspector. So we're going to hide it.
Yeah, we still want it to be public because we want other scripts to be able to talk to this script and say, oh, okay, I'm going to set those targets for you. We've spawned 2 tanks. I'm the game manager. I've put the tanks in and I'm going to tell the camera what to do. And so we want to keep it public, but we'll hide in inspector. So that's just what that's going to do. Currently, it's commented out so that when we test it before we've set up the game manager, we can still use it.
Okay, so it is an array of transforms. That's what those square parentheses, square brackets. What do you guys call those?
Square brackets.
Square brackets,
of course.
We'll call them that.
Why can't we say round brackets? You guys, killing me.
All right, so that is an array of transforms. It's all of the tanks, which we've called targets. Next, we've got our private variables. So, of course, we need a reference to the camera so we can access its size variable and change it. Then, these next 2 variables, don't need to worry too much about them. Basically, to damp the zooming and to damp the movement, we're using a function which requires a reference to how fast that's happening. And all we're going to do is store those. You don't need to worry about them. They will be used by the function, and that's it. The last one we've got is the desired position. So that is the position that the camera is trying to reach. So for us, that's going to be the average position of the tanks. We just want it to be in the middle of all the tanks that we have in our game. Currently, we're going to have 2 tanks, so it's just going to be the center of those 2.
Yeah, we've got a quick slide just to show that. So we find an average of the tank's position and we're going to set that camera rig. Remember, the camera rig is on the floor. We're going to set it to a point between those by just taking an average of their current 2 positions. And you'll see that in the script in a little while.
We're also going to use that desired position as the position that we want to zoom based on. So I'll try and explain what I mean by that. If we zoom based on where the camera currently is, then it's going to zoom to the wrong size because the tanks aren't there anymore. They're moving around. However, if we zoom based on where the tanks are, which is the average position, that desired position that we want to move to, then the camera is going to zoom to the correct size. So next, we've got our awake function, which we're going to use to set up the reference that we need. And remember that this is on the camera rig, and we're trying to find a component, the camera component, on a child. So we're using get component in children.
So ordinarily, one quick note about that is that if you make use of this, it's going to find, just like the audio source I mentioned earlier, it will find the first one. We only have 1 camera and 1 child object, so it's totally fine to use this in this instance. But be aware that if you're trying to find specific things, you might want to use another method.
Okay. So the next function that we have is fixed update, and we're using fixed update to move the camera because our tanks are moving with fixed update and we want to move along with them.
Yeah, so we've got physics objects moving around, so we use the same physics function to move the camera as well. Camera doesn't need physics because it's just a camera, it's not going to bump into anything, but it's keeping things in sync. So that's the important part to remember that.
So that fixed update is calling our move and zoom functions. For now, we're just going to go through moving, and then we'll try and address how the zooming is going to work, and then we'll come back to the script and go through that then. So the first thing that happens in move is it calls this function find average position. And then once it's found that average position, it's going to set the desired position to that. And then what we're going to do is use the smooth damp function to smoothly move the camera between its current position and the desired position. So then we've got this ref move velocity. That was the variable that we talked about that you don't really need to know about. Ref means that it's going to write back to that variable. So it's taking in how fast it's currently moving. It's going to do some more movement and then reset that variable to how fast it's now moving. The last parameter is the damp time. So that's how long it's going to take approximately. So let's look at the find average position function. So for that, what we're going to do is create a vector3, which is blank to start off with. So that's what that new vector3 thing is doing there. It's just saying create a new one, but leave it blank. Then we've got an integer for the number of targets that we're averaging over. And by default, we're not averaging over any targets, so we'll set that to 0 as well. So next, what we're doing is we're using a for loop. So this for loop is creating an integer called I, which is known as an iterator. Then it's going to keep going while I is less than the target's length. And for each loop that it does, it's going to add 1 to I.
So basically, remember that the targets is our list of tanks. So if this game was extended for more than 2 players, it would have that many in its list of targets. So if you think of m_targets as just a list, and we just say, okay, we'll loop through every single tank that we find in that array of targets. And then we'll do some things which are inside that for loop.
So this is a very, very standard way of using for loops. You have your iterator starting off at 0, going through an array until it's as large as its length. Okay, so in that loop, the first thing we want to do is check if the target's game object is active. So when a tank dies, what we're going to do is deactivate it. So we don't want to be trying to zoom in on a deactivated tank, so we're only doing these things if the tank is active. So what this line is saying is if the tank is not active, so that's that exclamation mark there, then continue. So continue in this case, what it means is continue on to the next iteration of the loop.
So we'll go back to here and do the next thing. The important part here is that you'll notice that we've got m targets brackets I. So that's basically taking that entry in the list. So I will start off at 0, and every array that you do in programming will start at 0 as well. And you can iterate 1 at a time. So, the second time it goes through, this will be 1, third time it will be 2 and 3 and so on. So it's basically saying, okay, this particular entry in the list, is the game object it's attached to active or is it not? We're specifically looking for it not to be, and then we continue to look for the next entry in the list. But if it is, then we carry on and we carry out these other instructions. Because we need the camera to be populated with how many tanks it can find right now. And the actual upshot of this is that at the end of the round, when you've got 1 tank that's been disabled and 1 left, is the camera will zoom in on the tank that won the round. So it's kind of doing both functions for us. Okay, so assuming that we're on a tank that is active, what we're going to do is add that tank's position to the average position. So that's that plus equals. What that's doing is saying, take the average position, add the average position to this new position, and assign it to the average position again. That's the plus equals. And then we need to increment how many tanks that we know there are, so number of targets that we've currently got. Okay, so we've added all of the active tanks to this average position. We've counted how many active tanks there are. Now we're outside of the loop. We can say, if there are some active targets, if the number of targets is greater than 0, then divide that average position by how many there is. In an ordinary instance with our game with 2 players, all it's going to do is say, okay, I've found 1 tank, I've taken its position, added it to the average and incremented how many tanks I've found. We found 2, so we've got those 2 together, and then we've just divided it by 2, and therefore we've got the position that's between those 2 points. And then the last thing that we do before we actually set it is just to say, okay, well, we don't want to change the Y position, so we say, the Y component of the average, set that equal to transform.position.y. So remember that this is attached to the rig, so it's just going to inherit that 0 and keep the position definitely at the ground for wherever that rig is moving. So we should note that that is just a little safety check just to make sure it doesn't go off the ground, because the tanks have all got their Y position frozen. If you remember, we had the constraints on the rigid body, so they shouldn't be moving up and down. Just in case something goes wrong, somebody puts in a piece of code that moves the tanks up and down or something, we want to make sure that the camera does not move up and down. So it probably never happened, but that's what that's set for. And then finally, we're setting the desired position to that average position. Okay, so let's talk about zooming. So following the tanks is easy. It's just taking the average of 2 positions and you've got 1 in the center. So what about zooming? So this is our typical kind of camera view. It's what the camera looks like at the start and what we've designed so far. So what do we know? Well, we know that the height from the center is the size, and we know that the size is what we use to zoom. And we know that the distance from the center to the right-hand edge is that size value multiplied by the aspect. So we gave you an example of aspect earlier, which was that 16 by 9. But this being our camera rig, we need to make sure that that tank is within the size, so we know that we can see it on the screen if that's true. So this axis handle that you can see is our camera rig pointing down into the world.
So that's the camera rig's local axes.
So in an example where our tank is at the top there, we can say that this distance in the y-axis is also the same as the size. So we know distance in y-axis is the same as the size. So we know that if that tank gets further away than the amount of our size, we probably need to zoom out. And the same goes for if it's going off the side of the screen. We know that this distance here is the distance in the x-axis for our camera, and that's also the size times the aspect. So those are the two kind of important factors that we know to keep it on screen.
So what we want to do is say, well, we know where the tanks are relative to the camera. We can work that out. So we can calculate a size based on it in the y-axis. We can calculate a size based on the x-axis. If we go through all the tanks, find out all the sizes it could be, and pick the largest one, then the tanks are all going to definitely be on the screen.
Yep. So you'll notice in this sum, we're saying distance is the same as size times aspect. But we know that on the camera, we can just tweak the size to zoom. So we just need to reverse that equation. So it's just distance divided by aspect gives us our size. Okay, so let's go back to the script and talk about how this zooming works in code terms.
Okay, so you'll notice this looks pretty similar to the move function. First off, we're finding the required size, and then we're smoothly damping towards that size.
Yeah, so orthographic size is size. So this is just the API for that value that you saw in the inspector where I was changing size and it was zooming. Orthographic size is that number.
So we've got the function that's finding that size, it's returning it. We're storing it in the float called required size. Mm-hmm. We're using the mathf smooth damp function to go between the camera's current orthographic size and the required size. And like we did before with moving, we need a reference to the zoom speed, like we had with the reference to the move speed, move velocity. And that's going to happen over the same period of time. So we're giving it the same damp time. So the camera is going to move and zoom over the same period of time. If you don't have the same, it's going to look really funky. So now the dreaded find required size function. First off, remember we want to find it from the desired position of the camera, not from the current position of the camera. So what we're doing is we're finding the desired position of the camera in the camera rig's local space. So do you remember we had that slide where you had the y-axis and the x-axis shown? What we're doing is we're finding the desired position of the camera in that space. So it might be up a little bit and right a little bit, something like that. Then what we're doing is we're creating a size variable, which we're starting off at 0. And as we go through all the tanks, we're going to find all the sizes that it could be, and at the end, pick the largest size.
Yeah, so you basically want to say that, well, we've got 2 tanks, and then whichever one's furthest away, we want to zoom to accommodate that one, and therefore we'll capture all of them.
Okay, so like we did before, we're looping through all the targets. So going through all the tanks from 0 to just before the length. And again, if that target is not active, continue on to the next target.
So we go back to the loop, keep looking until we find a tank that is active and do something about it.
Next, what we're doing is finding that target in the local position of the camera rig. So you remember in that local space, we want to find it up and across, but the world space doesn't look like that. That's just the camera rig's local space. So what we're doing is we're saying, okay, so the tank that was at the top of the screen in the camera rig's local space is just going to be some value in Y. If it's on the right of the screen, it's going to be some value in X. So the next bit, we found the desired position of the camera rig in the camera rig's local space, and we found the tank in the camera rig's local space. But remember, we want to do this from the desired position of the camera. So this is quite tricky to get your head around, but imagine those slides that we saw, the tank on screen. Imagine instead of that being the camera rig, that's the camera rig's desired position. That's all that's happening here. So now we've found that vector from the camera rig's desired position to the tank, and we're going to calculate the size. So we're saying the size is the maximum of its current value or this new value that we're calculating. absolute value of the y-axis of that vector. So the reason, again, it's the absolute value is that if the tank was at the bottom of the screen, you don't want a negative value for size. You still want the positive value. You're only interested in the distance, not whether it's positive or negative. And again, for the x-axis, we want to choose whether it's size that's the largest or this mathf.abs of the x value of that vector, the x component, divided by the aspect. Because you remember from left to right, it's size multiplied by aspect. So to find size, it's distance divided by aspect.
So one key point to mention here is we've got two things that look like they're doing the same thing to this size variable. They're not. They're basically deciding which is bigger. So we're saying, is the size currently bigger than this y distance? And then it will return whatever that is. So then size the second time around is currently set to the biggest value of those two. Then we're then comparing whether it's currently bigger than the y value. So we're just finding that distance away and saying, okay, well, x or y, are they bigger? Okay, well, that one is. And then size is naturally returning that because max just picks whichever one is bigger and saves it back to that variable. So by this time, size is currently the furthest value. Then we just add on the screen edge buffer just to give it a bit of extra distance so that the tanks will definitely fit into the zoom. And then finally, what we want to do is make sure that we're not too zoomed in, so we want to apply that minimum size. So we're choosing the maximum of the current size that we calculated or the minimum size. So if size is still 0 because it's so zoomed in, then we'll choose 0 or 6.5, or we'll choose 6.5. Yeah, so minimum size, remember, was 6.5. We don't want it to zoom in too much because you'd not be able to see anything properly. So we find an absolute minimum that it can be and make sure that that's the case. And finally, we have a return at the bottom. So this function will actually return something. So it's returning that value. So wherever we see find required size used, so that's here in the zoom function, then it's getting that value returned out of it. And the last part of this wonderful script is set start position and size.
Okay, so quick thing to note is that this is a public function, so it can be called from outside of the script. What we're going to use this function for is when we've got a game manager, we're resetting the scene at every round, but we don't want the camera to smoothly move to that new position. We just want it to find the right size, find the right position, and set straight to those. So that's all we're doing here. We're finding the average position, setting the transform.position straight to that, and then with the camera.orthographic size, finding the required size, setting it straight to no smooth damp. Okay, if you understood all that, friggin' awesome.
So we appreciate that this is a difficult and confusing concept. Like we said before, there's a commented version of this script in the completed folder. So do have a look at that afterwards. And so let's go back to our slides. So the camera rig is what we need to actually assign these targets to. So currently we've got one target, one tank, okay? So what we're going to do is go back to Unity. What you'll have noticed is that we've got a targets array because of the square brackets that we had in the script. So that gives us an expandable arrow. So if I expand that, I can see size 0. So that array currently doesn't have any items that we can put into it. What we could do is we could give it a size of 1 and assign it. But a quick way to assign things is just to drag on the thing you want. So I'm going to drag tank. And you see when I hover over the word targets, it gives me a little green plus icon. I can let go and it will populate that with a 1 and assign the tank to the first element in that list. Okay, so one more time is selecting the camera rig. You can see targets is here. It doesn't need to be expanded. Doesn't matter if you do or not, but we were going to just drag the tank, which is our target for the camera to look at, drop it onto the word targets, let go, and you should see you've got size of 1 and tank is listed in there. Just to remind you, in the brackets there, in the parentheses next to tank, I should say, we have transform. That's the type that it's looking for. So with the tank, the position is stored in the transform component. So we just look up that position via that. And so that tank is the reference it's got. Later, when we have a game manager, we will hide this targets variable in the inspector. We'll uncomment that line that says hide in inspector, and that will disappear from the inspector totally. The game manager will then populate that list for us. Cool. Save your scene. Okay, so we should now be able to play our scene and drive around. It should look like this. We can now explore our wonderful world up the desert.